What if one day, everything we confidently call scientific truth turns out to be only a temporary way of seeing the world? Imagine living centuries ago. Every book, every university, and the greatest minds tell you, Earth stands still at the center of the universe. This was not superstition. This was accepted science. But then, a new idea appeared. It did not just correct small mistakes. It transformed humanity's entire place in the cosmos. Thomas Kuhn called these rare moments when civilization changes how it understands reality, scientific revolutions. For a long time, we imagined science as building a giant tower. Each scientist added another brick. Each discovery made the tower higher, moving humanity closer toward final truth. But when Thomas Kuhn examined scientific history, he noticed something unusual. The greatest breakthroughs were not like adding new floors to an old building. Sometimes, humanity had to break the foundation itself and build something completely different. Kuhn discovered that science was not a river flowing smoothly forward. It was more like different eras in history. Within each era, scientists lived inside a shared intellectual world. They accepted similar assumptions, used similar methods, and agreed on how problems should be solved. These invisible rules determined what was considered reasonable and what was ignored. Kuhn called this hidden structure a paradigm. A paradigm is powerful because it does not only provide answers, it decides what questions we are able to ask. It is like invisible glasses worn by humanity. After looking through those glasses for long enough, we forget they exist. We begin to confuse our view of the world with the world itself. But history shows that the greatest discoveries often begin with things the old glasses could not reveal. During what Kuhn called normal science, scientists do not try to overthrow existing beliefs. They work inside the current paradigm. They measure, experiment, improve theories, and solve increasingly difficult puzzles. It is like chess players searching for brilliant moves. But nobody questions why the chessboard was designed this way, or whether a completely different game exists. But over time, strange things begin to appear. Experiments produce results that do not match predictions. New observations no longer perfectly fit old theories. At first, scientists often see them as small errors that need fixing. But as more and more exceptions appear, a dangerous question begins to form. What if the problem is not the data, but the way we see the world itself? Kuhn called these problems anomalies. A few anomalies cannot destroy a major scientific system. Scientists will usually adjust existing theories to explain them. But when too many anomalies accumulate, confidence in the paradigm begins to weaken. Small cracks in the wall of knowledge slowly become signs that a much larger crisis is approaching. This is the most dangerous but also the most creative moment in science, a paradigm crisis. Ideas once considered strange begin to receive serious attention. Questions that were ignored return again. When the old system can no longer explain reality, humanity is forced to imagine a bold possibility. Perhaps we need an entirely new way of seeing. One of the most famous examples was the Copernican revolution. For centuries, the Earth-centered model dominated human thinking. As astronomical observations became more accurate, the old system required more and more complicated adjustments to survive. Copernicus did not simply offer better calculations. He changed the fundamental question: what if Earth was not the center? What makes scientific revolutions difficult is that they do not only change formulas or numbers. They transform how humans understand reality itself. After Copernicus, the universe was no longer built around Earth. After Newton, the heavens and Earth no longer followed separate rules. Each revolution opens a new world that was almost impossible to imagine before. But even the greatest theories do not last forever. For more than 2 centuries, Newtonian physics seemed to unlock the mechanics of the universe. It predicted planetary motion, explained gravity, and became a symbol of scientific power. Many believed the fundamental laws of reality had finally been discovered, but at the edges of knowledge, small anomalies began to appear again. In the early 20th century, Einstein did not simply add another detail to Newtonian physics. He changed the entire playing field. Space and time, once considered fixed and absolute, became flexible and connected. This was exactly Kuhn's point. A new paradigm does not just give different answers. It allows us to see a different universe. But revolutions like this are rarely accepted immediately. According to Kuhn, old paradigms do not disappear simply because new evidence appears. Humans become attached to familiar ways of thinking, especially when they have worked successfully for a long time. A new idea must not only win through data, it must transform the imagination of an entire generation. This was one of Kuhn's most controversial ideas. He argued that science is not simply a perfectly objective process where data automatically leads to conclusions. Science is practiced by humans, with beliefs, traditions, and limitations in thinking. This does not make science weaker. It reveals that science is a far more complex journey than we once imagined. After its publication in 1962, Kuhn's book changed how humanity viewed science itself. The phrase paradigm shift moved beyond laboratories and became a way to describe major transformations in society, technology, economics, culture, and how we understand ourselves. A new idea may not simply improve the old world. It can create an entirely new one. Think about modern revolutions. Computers did not just help us calculate faster. They changed how humans process information. The Internet did not just connect more machines. It transformed how society communicates. Artificial intelligence may not simply be a new tool, but the beginning of an entirely different paradigm. But the most fascinating question is this: if every generation before us was limited by its own paradigm, are we trapped inside ours today? What truths might be right in front of us that we cannot yet see? What questions exist that we have not even learned how to ask? The history of science teaches us humility. The smartest people of the past were not wrong because they lacked intelligence. They simply saw the world through the tools and ideas of their own time. And most likely, the future will look back at us in the same way. Perhaps the greatest strength of science is not that it is always right. Its true power lies in its ability to change itself. Unlike fixed belief systems, science can break apart the very ideas that once made it successful, in order to move toward a deeper understanding. The Structure of Scientific Revolutions is not only a book about science, it is a reminder that the way we see the world can be just as important as what we see. Because sometimes, the greatest discovery is not finding a new answer, but learning how to ask an entirely different question.